I call this section More Fun with Lines. The goals. Number 1, to graph linear equations using x and y intercepts. Number 2, to graph horizontal and vertical lines and find their slopes. Number 3, to determine if two lines are parallel, perpendicular, or neither. Number 4, to solve linear equations by graphing. And number 5, to identify linear equations. Let's start with this example. Okay, we want to graph 3x minus 2y equals 6 using x and y intercepts. Okay, wait. Let's go back to a previous picture. What do I mean by an x-intercept?
So the line intersects the x-axis.
Good. So I'll point it out in purple here. So this point right here, whatever it is, it's 2 point something, right? Whatever that point is, where it crosses the x-axis, that's the x-axis, that's the y-axis. That point is the x-intercept. And then we can actually identify the y-axis a little more exactly, or the y-intercept rather, a little more exactly here. Isn't it this guy? 0, 2. Oh, we plotted the y-intercept. So the point where the graph crosses the y-axis is called the y-intercept. Nothing new there, right? Pretty familiar territory? So back to this problem. So how do you get the x-intercept symbolically using the equation? So the idea is if you want the x-intercept, then you can plug in 0 for y. Wait, let's go back to the picture. What's the value of y where the graph crosses the x-axis? What height is it at? 0. That's where that comes from. If we want the x-intercept symbolically, we can plug in 0 for y. And then likewise, if we want the y-intercept, what's the value of x right there? On the y-axis, the value of x is 0. So you set x equal to 0 to get the y-intercept. If you ever forget that, you can just draw a picture of a generic line, you know, oh yeah, x has to be 0 there, so to get the y-intercept, set x equal to 0. Oh yeah, y has to be 0 there, so to get the x-intercept, set y equal to 0. Okay, so to get the x-intercept, set y equal to 0. Oh, well, that means I plug 0 in right there, so what happens? 3x minus 2 times 0? What's going to happen to that entire term? It's 0, so do you even bother considering it? No. And you get 3x equals 6. So what does x have to equal? If 3x equals 6, what does x have to equal? X equals 2. How did I get that? Divide both sides by 3. I didn't show my work here. Eventually you want to get to the point where you don't have to show that work. It looks a little neater. But if you're not there yet, that's fine. Show the division by 3 on both sides. Okay, x equals 2. Now that's not quite how we write it. The x-intercept is technically a point, an ordered pair. So how do we write it? Other way around though. It's x equals 2, so it's got to be 2 comma 0, right? Yeah? Okay, there it is. Let's find the y-intercept now. Okay, what do you think we're going to do to find the y-intercept? Set x equal to 0. And then what's going to happen to this whole term or when we set x equal to 0? It's gone. It's gone. Trying to make math exciting. It's gone. Little inflection there. Does that help? No. All right. So it just becomes negative 2y equals 6. Okay, so what does y equal? Y equals negative 3. So that's the y-coordinate of the y-intercept. But what's the y-intercept actually equal to? Or what is it? It's an ordered pair, so how do you write it? 0 comma negative 3. And then we want to graph this thing, right? 2, 0. So I'm just going to throw in a couple of scale marks. I'm going to go by ones. You don't have to, but it's convenient here to go by ones. So 2, 0 I'm going to plot, and then I'm also going to plot 0, -3. So 2, 0, and 0, -3. And then I'll live life on the wild side and try and draw a straight line by hand. There you go.